Welcome, welcome, ladies and gentlemen. Here we are, another glorious day. We are going to be working today on solving systems with substitution. There are other ways to solve a system of equations, but today we're going to focus on substitution. So we're going to look at the first step. Our first step says to solve for x or y. One or the other. We can pick. So luckily, algebra has options. So we're going to take a look at these two equations before we choose. If we solve for x or y, we're going to look which one seems to be the simplest to solve. I could pick either or, but I need to only pick one. We're more comfortable with a y equals approach. I'm not going to do that. I'm going to go rogue, and I'm going to go ahead and solve for x in the second equation. Yes, you can do that. Again, algebra is about options. So we're going to look at x plus 4y equals 1. Our goal is to isolate the variable x. So we want the x by itself. So we're going to subtract the 4y minus 4y. And again, I'm writing it aside over on the side of the 1 because, well, are these two common terms? Are they like terms? No, they are not. This one has a y, that one does not. So we cannot combine them, so I do not write them one over the other. So I'm left with x equals 1 minus 4y. And I just finished solving for one of the variables. Next up, we're going to go ahead and substitute and solve. So I used this equation. Now I'm going to go ahead and go to the other equation. So my other equation says 2x plus y equals 9. So see my variable x? Well, I know x is 1 minus 4y. So I'm going to go ahead and substitute that in. So I'm going to go ahead and replace the x, substitute the x with 1 minus 4y. And then copy down everything else and make sure I have that copied correctly. I'm going to go ahead and use my rules of distribution and solving with inverse operations. So I'm going to go ahead and distribute this 2, which also means multiply. So 2 times 1 is 2. And then 2 times minus 4y is minus 8y plus y. Don't forget that the 2 only gets distributed into the terms that are inside the parentheses. Only. The y over here is not in the parentheses, so I don't distribute it to this one. I only distribute into the parentheses. Now I'm going to combine like terms. This one and this one are like terms. So this is a minus 8y plus y. So I'm going to combine these two and I'm going to get 2 minus 7y equals 9. I'm going to continue solving. Go ahead and pause the video, solve, and let's come back and check in a little bit. Alright, so after solving with inverse operations, you should have gotten y equals negative 1. Don't forget, a positive divided by a negative is still negative. So this is one of my variables. Remember, I have two variables. I have x and y. So I'm going to use this value, and I'm going to go ahead and substitute it into one of my equations and solve for x. So I'm going to go ahead and go with the first one. Let's see what happens. So 2x plus y equals 9. Substitute this value we just found. So 2x plus negative 1 is equal to 9. I'm going to solve for x now. Do I need these parentheses? Well, not necessarily. So you can go ahead and take them out. Some of you are comfortable with taking them out of the parentheses. That's fine. I'm going to go ahead and solve for x. Go ahead and pause the video, come back and check your solution. Alright, so after solving, you should get x is equal to 5. So now I have two values. I have the y and the x. We've seen this type of thing before, an x and a y, and we've seen it at the intersection. So the solution to this system of equations is the point 5, -1. If I was to graph these two lines from the very beginning, if I was to graph these two linear functions, my solution or intersection would be at 5, -1. So that's how we do this one. Okay, so now we're going to go ahead and look at example number 2. Example number 2 already has one of the variables solved for. So we already have y equals 3x. So that saves me some time. I don't have to go and solve anything, or I don't have to solve for a variable because it's already done for me. So I can go ahead and skip straight on to substitute and solve. So I already know what y is equal to. So I can go ahead and put, well, I'm going to use x plus y equals 8. I'm going to substitute this into the y. So x plus 3x is equal to 8. I'm going to go ahead and solve for x, combine my terms, and solve with inverse operations. Go ahead and pause the video, solve it, and come back and check your answer. All right, so you should have gotten x is equal to 2. This is one of them. Now I take this and I go substitute it into one of my equations. Does it matter which one? No, it does not. So I'm going to go ahead and take x equals 2 and pick one of these. Well, the easiest one, it looks like, is this one, the very first one. So I'm going to go ahead and take y equals 3x, and I'm going to go ahead and substitute the 2 in, so it'll be 3 times 2. So y is equal to 6. No solving involved. As far as like adding and then division, I didn't have to do any of that. It was straight out multiplication. I took the x, substituted it in, and I got y equals 6. I'm almost done. Again, remember, we have an x and a y. So the final solution to this whole system of equations is 6. That is my final answer. On to example number 3. You're on your own. Let's see how you do.